was founded in 1992, and we run themed research programs of 1 to 6 months long, all areas of pure maths and all application areas, with around 40 odd scientists at any one time, and workshops obviously with a lot more as we have today. As part of our reach out, obviously getting someone from business to come for 6 months is perhaps rare. We've run now a number of these open for business meetings in which whose aim is to bring together people from business and industry with leading scientists. And the goal is not to solve any particular problem that we might have, let's make that clear, but they should actually be able to come and enjoy and appreciate the fantastic environment that there is here for working, and I hope that you'll have a really stimulating time today. We certainly have a very interesting list of speakers. So the format is that there will be 4 talks of 25 minutes with a few minutes for discussion, and we'll then break roughly at 4 o'clock. We'll break for tea and reconvene at 4:30 when there will be a panel discussion. And the panel will be the 4 speakers plus Dr. Bill Janeway from Warburg Pincus. I'm sorry, I have to say that I had an email from Willem Beuter just this morning saying he just returned from abroad and he was not well and he was too unwell to travel. So I sent him best wishes for a rapid recovery. So I'm afraid Willem won't be on the panel. The chairs for the sessions are Howard Covington. Howard has been there, seen it, done it, was in New Star Asset Management, graduate of Cambridge in physics and maths, still infected with interest in those subjects. So Howard will chair the speakers, and the chair for the panelists will be John Eathwell, Lord Eathwell, who's a professor in economics here. And John will be joining us very shortly. Just some practical announcements. Firstly, mobile phones off. It's not that they're just annoying when they ring, but actually we get interference somehow picked up in the room. We are recording the seminars with the permission of the speakers, I'm very pleased to say, and presuming we get the copyright correct, we'll be showing them on the web afterwards. In the recordings, if you have any questions, please just speak up, because there's an array of microphones and questions are also picked up. So I think probably without any more, well, I should thank people, obviously. Firstly, the speakers, obviously the panelists and chairs. And I think without more ado, I'm going to hand over to Howard to get us going. Thank you.
Ladies and gentlemen, it's a great pleasure and honor to be here to introduce the amazing talented set of speakers we have this afternoon. What David didn't mention is that I think he asked me to be chairman so that I could learn something and correct my mistakes that I've been making in the city over the last few years. Anyhow, so we can all learn something. Let me get on straight away and introduce Professor Hashem Pesaran, who's a fellow of Trinity College and professor of economics here. And as you can see, he will talk on the future of quantitative finance. Professor.
Thank you very much. Thanks so much for organizing this meeting. I'm looking forward to learning from other speakers and the discussions. My presentation has been basically based on what I was directed to do, to look at what are, or if any, limitations of economics and finance theory over the past, say, 50 years, and how does it may affect the way the markets have been operating or likely to operate. I'm going to focus on something which I've been doing since I published my book on similar title, The Limits to Rational Expectation, back in 1987. So as you can see, some of these topics are not new to me. I'm sure it would not be new to many of you here either. But I hope that I will relate it more directly to some of the financial, if you like, theories and practices. And that would be obviously the focus of my talk. So basically, I'm going to start by looking at what I call the foundations of modern financial economics. I'm mainly focusing on the theory of finance and the way it's practiced by academia. I'm not going to say anything about its practice in the marketplace. They are not necessarily the same. And I'm going to relate some of these foundational issues to the problem of asset pricing. I'm going to basically focus on arbitrage asset pricing. I don't say much about option pricing and so on. But you see my argument is the same applies. The same points would apply if you deal with derivatives markets. And then I'm going to actually focus on the fundamental issue of efficiency of the markets and the issue of arbitrage, and say how our understanding from a theoretical and econometric perspective has bearing on this fundamental concept. Without further ado, let me just start. It's obvious that all economic decision-making, all decision-making, but we are dealing with economics and financial decision-making, are subject to major uncertainties. I mean, if the world was predictable in a significant way, obviously we wouldn't be all sitting here and discussing the issues. But then how to model this uncertainty obviously is very important, but has been controversial. Although what is interesting, over the last 40 years, I time it 40 years, I think 1971, 72, and maybe a bit later, that when Mute wrote his article back in 1960, but it wasn't really utilized much in, if you like, academia, leave alone practical situations. But it was really the work of Lucas and Sargent, which then established the rational expectation hypothesis, which has come to dominate the economics and finance theory, and largely also the practice of it, in the way we interpret the markets over the last 40 years. And we need to know why it has happened and what are the, if you like, issues concerning this domination. Now, according to the rational expectation hypothesis, subjective characterization of uncertainty, either through learning or through full understanding of the world, would come to become the same as objective probability distribution of the events. Now, this has got obviously a lot of issues behind it already. The reason I came to the problem is about having had a bout of practice as the director of Central Bank, of the research department of Central Bank of Iran. Because of revolution, I came back to academic, and this hypothesis just come on the scene. And being an econometrician, the first time I looked at this hypothesis, I said, how could it be true? We all in econometrics or statistical analysis, we spend all our life to identify a model and we know it turned out not to be correct. So how come everybody else has figured out this model and I haven't yet? So the question is, how does it actually work then? That it's, although it's so incredible in terms of some of its assumption, why is it so attractive? I think the reason actually is answered the question in a neat way. It is mathematically elegant and allows a model consistent solutions, which is closed form solutions. So you don't need to assume anything outside your model, because you can use the model in order to generate the expectations. And also nicely fit with equilibrium theory, which I'm going to talk about. So because of these three features, it's been so fundamental. Some of the work I do also in terms of the theory, I use it. But I know its limitation. So basically, these are the main issues which I'm going to address. Now, clearly, when the rational expectation hypothesis came along, was less demanding than the perfect foresight, which was before it. But it wasn't that much, if you think about it. Why is not that much become clear as we go along? Because it still requires the economic agents to fully learn the true conditional probability distribution. Instead of learning the actual point estimates of everything, you learn the probability distribution. So basically, it's a full learning. It is like a perfect foresight in a stochastic world. You know, if the world was stochastic, it's become like that. So basically, in a way, what is so implausible about it in some way is because it's somehow saying that people are fully learning the process. Of course, you could discuss under what condition this learning become complete or not. I'll come back to that later on. The argument has been also plausible because a lot of people who do as if theorizing, like Milton Friedman, which was one of the architects of as if theorizing in economics, they would say, look, if you didn't have the rational expectation artifact and the model, then it would say that people make systematic mistake. Those of you who remember adaptive expectation, when inflation is rising, you always underestimate it. When inflation falls, you are overestimated if you use adaptive expectation. And these systematic errors obviously doesn't make sense. People should realize you shouldn't be making systematic errors and correct it. Now the trouble is, you go from that plausible point of view to another implausible point of view. We say, therefore, because of that, then nobody makes any systematic errors anytime. That is, to me, is a problem. I mean, is this, we should come back to that and why that's the case, actually. So, in a way, the second problem with rational expectation, which I identify in my work as early as back in 1987, is that there are certain events in the world which are what I call behavioral, nothing to behavioral finance. Your behavioral here means that basically you are trying to form expectation about other people's actions and motives, which obviously also what Keynes had talked about in beauty contest and so on. So basically, when you're dealing with forming expectation about behavior of others, that becomes strategic, and it's very difficult to actually know what the learning is. So therefore, while you would be learning about the amount of rainfall and the distribution of exogenous, what I call exogenous uncertainties, it creates a problem as how you can actually learn about uncertainties which are behavioral. At least I call it behavioral. Some people call it endogenous. Now, the rational expectation is actually is a very good, in my opinion, working hypothesis when you're dealing with stationary ergodic processes. Because if you have a stationary process, people have actually done work on learning, including Sargent, who moved away from this extreme rationing to the learning, has done a lot of work on learning himself with our colleague here, Seppo Honkapai, who was here. All the people who have done learning, when you look at a stationary process, you will learn eventually. Because if the world is stationary and there are no breaks in it, there are no dramatic changes in the world we observe, in the sense of a statistical sense being stationary, like quite a strict assumption, then you learn. So I think that's a very good hypothesis in that setting. The question is the world we live in, is it stationary? And that's the question we need to address. That's exactly the point. That why is the world is non-stationary? I learned that from James Mead, in the sense that the first thing you learn is that, look, if the economies are driven by technology, if you think about it, technology is a fundamental force of economic progress. It shapes a lot of other things, institutions, countries, governments. If that's the case, we know that technology is not predictable. Because if you could predict it, how could you be innovative? The way the macroeconomists in my profession model the technology, basically they say it's random, but basically it's a stationary around the deterministic trend. It goes back to stationary. Because if you took it as a trend, if you knew that technology will grow about 2% forever, and that's not going to be changing, then what is round is a wiggle, basically. So we are spending a lot of time about looking at deviations from a trend which are all stationary again. So therefore, is it the right way of modeling technology and institutional change? To me, it is not. Maybe in some circumstances, when the world is stationary, maybe, but not in general. So the problem then is that actually the same has happened in finance, that they have taken models of asset pricing. For example, look at the option pricing or derivative pricing. They always have an assumption about what is the model which underlies that option pricing model. Usually taken to be a Brownian motion, obviously with a volatility changing and the drift, but then the drift is often assumed to be known, even if it's changing. Now, the problem is that as soon as I show you, as soon as you say we don't know the drift, I'm going to claim to you, and I'm going to prove it, I've done in a number of other papers as well, that you cannot define a fundamental price of anything, because you are dealing with a forecast of uncertainties which go way into the future. The present value does not exist. So I'll come back to that. So basically, in reality, I don't see myself anything wrong with the theory, if you ask me. I've thought about it very carefully. I don't see anything wrong with the asset pricing theory as such. What is wrong is the assumption about what we know about the underlying forces, what we know about the drifts and the volatilities. This is the problem, that we haven't learned it yet. Of course, if the world were stationary, we would have But because not, then it doesn't mean that we would. And every time that we think we have learned something, something jolts us, and again we go to the period that we don't know what is the actual fundamental parameters of our model. So I believe that financial systems, I'm using the word from mathematics and physics, that it really has to be more modeled like a complex system, not like a model which is a stationary around a deterministic trend. That is the difference. I think economists have spent too much time on a stationary world. There have been some attempt to move away from it. I'm not saying all economists. I'm talking about the mainstream economists. Generally speaking, it's fine. If it's not a stationary, you say, I know how to make it a stationary. You either first difference the variables, or you take a deviation from some deterministic trend. And then you say, what is left is a stationary, let's just get on with it. That's the problem, in my opinion. So I don't see anything wrong with the modeling structures, or as I come to talk about arbitrary asset pricing, they are really very good models, in my opinion. It's just what are the ingredients, whether we can have all the ingredients of them. So in complex system, basically my argument is complete learning is not possible. If you look at the whole learning literature, which has expanded the last 30, 40 years alongside the rational expectation, they all use a stationary structure in one way or another and end up saying the learning become complete. I mean, if there's any other example, I'm happy to hear it. Okay, now the second problem is long horizon on learning. So far, we have been dealing with learning just tomorrow, or maybe the day after tomorrow, short-term learning. In finance, you need long-term learning. Not in all activities of finance. If you do, in hedge funds, which you only look at between a day or one day to the next, maybe you're not worried about this. But if you look at the allocation of assets in the economy, or you want to have a pension funds, you need to worry about the long-term values of assets that you are dealing with. Those even who look at option pricing, they take a longer horizon than very short term. So if you take a long horizon, the trouble is that even if you take the simplest possible problem, which is say that the fundamental price of an asset, this PT, is, I'll use an H here because I'm going to find out what happens, what H goes to infinity. For a finite H, what is the present discounted future stream of dividends? Now, the discount I've assumed to be constant. I mean, you could have a stochastic discount. We show in the paper, it doesn't make much difference. So long as you put some bound on it, it's just the same problem. So basically, the question is, how do I learn about the dividend process way into the future? Remember, I'm going to calculate it for all periods ahead. Now, if I knew the dividend process, suppose, let's take the simple example, example one. This example is one where the fundamental price exists, but does not have moments in a distributional statistical sense. Of course, if I knew the true parameters, the existence of moments is not an issue because it's a deterministic value, right? So in this example, let's take the simplest possible model for dividend, which is the first order autoregressive with constant variance and the rho. These are not essential to the argument. You could have volatility changing and so on. But then you can, this is a basic result which says that price dividend ratio is constant. I mean, a lot of people have developed very complicated model arrive at the same conclusion. Okay. Now you say, all right, if that I don't know what the delta, delta I know, rho I don't know what the rho is, then you need to go and estimate the rho. Now, but the problem is we only can estimate things from a finite amount of time. Today, 1,000 days from now, before, right? We have a finite amount of time. Okay. Now, if I have a finite amount of time with the capital T being finite, if I go to and estimate the rho, I run a OLS, least square regression, does a very good job here, it's the best thing we can do. Then you work out what is the present value, but I go H period ahead. That gives me this expression. Now I want let H go to infinity. Now, if you let H go to infinity, although delta to the power H is going down, go to 0, so that controls some of the problems you may have. But imagine H is any number. H is 20. Okay? Now, as soon as you have H 20, this simple model requires that H has to be H has to be less than T minus 1 for this expression to have moments. Because you're raising rho to the power H. First moments. If you want second moments, H has to be, T has to be way larger. So therefore, there exists a H, where this term inside this summation would not have a moment. No moments, not only the mean. Doesn't have means, doesn't have variance, doesn't have anything. Now, a lot of you then say, what is the price of this fundamental price of this asset? You tell me. In fact, Chuck Mansky was here. He said he had gone around and asking the question from a lot of his colleagues, can you tell me what's the fundamental price of any asset? I challenge anybody. If you can't do it in this simple context, which meaningfully saying what it is. Let me give you a worse problem now. Let's give you a second problem. I done this with another paper which came out in Econometric Reviews. Some of you may have seen it. Let's take the simpler not a simpler problem, a more realistic dividend process, and let's assume that we know rho is 1. No, we don't want to estimate rho. It's a random walk model, right? That's what the rho is. Now you have a random walk model. Now, however, what is the random walk problem? It says that the growth of dividend is mu, again fixed. I'm not allowing mu to be breaks in it or instability. It's just a simple vanilla model that everybody uses in finance. Trust me, right? This cannot be simpler than that. Now, in this model, where mu, which is a drift, and sigma volatility is fixed, we now can work out what is the asset pricing model for this as well. So in this example, it's a bit more complicated because of the fact that we have this log of dividend. You have to take exponential of this in order to get mathematically solve it, but that's not that difficult. Again, if you use mu and the sigma, and now you need to know also the distribution of epsilon. Now, if you knew mu and the sigma and the distribution of epsilon, in linear model, you didn't need to know the distribution of epsilon. In this model, you do. If you work it out, that becomes moment generating function. The first thing arises, does the moment generating function of epsilon exist? If it is a Gaussian, it does exist. But if it's a t-distributed, it doesn't exist. So therefore, if there was a fat tail distribution, even if you knew mu and a sigma, this thing does not exist. A fat tail distribution. And that was pointed out by Givicki in 1991. Now I'm saying, let's say now the world is very neat. There are no fat tail out there, right? Just take the even extremest case, which we know is not even true. Now, in that case, the moment generating function, say Gaussian, exists. But then I don't know what the mu and the sigma is. Let's assume that the condition for this to exist is satisfied. In other words, sigma and mu are such, and delta is basically small enough so that it becomes less than 1. So therefore, we have this existing. Everything exists. Now we want to learn about the mu and the sigma. How do we learn? Rational learning, Bayesian. We are a Bayesian learner. So I start some priors. Lower bar case means there are the prior values. And then I would then calculate the posterior, which is upper bar, and the upper bar. These are the posterior mean. These are the posterior variances. Then I work out what the pH is, the price truncated at h being the horizon. Look what happens here. The first time I did it, my co-author Alan Timmerman didn't believe it. He has to spend a few minutes to work it out that it's actually true. This is the term you would get without uncertainty. Without uncertainty of the parameters. You are still uncertain about the word. The sigma is still non-zero. This term, if you didn't have this bit, this would be bounded. But the trouble is, now you have h squared divided by t. This term, as h becomes larger, this h squared divided by t becomes larger and larger. So therefore, because t is finite, this blows up.
What is h?
H is a horizon. Remember, the model is that the present discounted future of a stream of dividend. So that's what value, the fundamental value of any asset. Doesn't exist. Okay? Doesn't exist. Now, how do we now talk about a reasonable allocation of asset in this economy? That's my problem. People haven't looked at these learning problems. They actually haven't really understood that you really need to learn about the infinite sums, which is quite a difficult problem. So therefore, there is an additional problem here. Now let me just move on. This is a learning bit. Let's now move on to the equilibrium concept. There are two pillars of this literature. Is a formation of expectation as equilibrium. Now, if you look at this, obviously, as I already mentioned, rational expectation fits very well in equilibrium context. And then, given the time, basically, you will see that here the rational expectation equilibrium, which also underlies all of the finance and economics, has major assumptions that the markets obviously clear at equilibrium prices. That's a definition of equilibrium price. Every agent knows the relation between equilibrium price and the private information of all the other agents. The information contained in equilibrium price is fully exploited. Of course, there are issues that whether it's possible, whether such equilibrium exists. My view is that really, given the shortness of time, I don't want to spend too much time on it. There's a very nice article by one of the speakers, Farmer and Giannakopoulos, which look at these pros and cons of equilibrium. And then we could discuss them in a panel discussion. But the bottom line here is that effectively the model doesn't really explain the real world. That's my problem. Because it says whether such an equilibrium exists, pedagogically very useful, very helpful to know equilibrium exists or not, and very interesting to know what are the qualities of that equilibrium going to be. But what happens when you actually want to know, are you in equilibrium? How long it takes if you go out of equilibrium? How do you get back to equilibrium? How the equilibrium get established? This question has been asked repeatedly, but I haven't seen any answer over the last 40 years. Let me just now move on very quickly. That my view is that what I take from economics, which I learn a lot every day, you need to understand these models and so on. I'm not criticizing these models. I'm saying they are limited in the way they can be utilized. The only thing I can use them in my work is to find out the long-run relationship that these models suggest and plug and embed this long-run relationship inside a complex dynamical system and try to find out how empirically the economy adjusts to this equilibrium. The reason I believe is that effectively the social, institutional, political context all determine the outcome of economic forces. No, it's not only economics. Because of that, you cannot write an economic model and tell you that you understood the world. That is too complacent. You just cannot do it. You have to somehow embody your knowledge of economics in a complex system and then use empirical analysis to understand the deviation from equilibrium and the cost of it and the timing and so on. They may be imprecise, may be difficult to identify, at least we have a proper agenda. So basically, the second thing I have, which I don't have time here, maybe I should come back to it when we come to the panel, because I just want to make sure that we are on track. So what I wanted to do here, I'm just going to discuss it, just what is the implication for asset pricing, which is the financial aspects of the problem. Now, a Ross model, I've chosen APT. I think it's a really great model. I mean, it's a really rich model because in a way, it doesn't build on equilibrium. It builds on arbitrage. Arbitrage is fundamental in economics because it is clear that it's through the act of arbitrage that the prices and the, if you like, any kind of disequilibrium will give rise to exploitable opportunities, and those exploitable opportunity then has to be utilized, and that would have effect on the outcome. Now, what is also nice about APT, you can easily generalize it into a general equilibrium type context rather than just looking at one individual decision. However, if you read Ross, and then I've done some more recent work, with Paolo Zaffaroni, basically what it turns out that you really need to assume that in the APT or mean variance application, all of that, that you need to know what are the factors that drives the pricing and what are the factor loadings that basically affects the prices, right? You don't know those either. Now the question is, under very restrictive assumption, if you basically, people didn't know those factor loadings, they didn't know the factors, they disagreed with each other. However, their disagreement is totally random and independent of everything else, then the market would average out to a solution. But now, the trouble is, it doesn't work when there's a correlated behavior. When people use the same newspaper, or there's a herding, or there's a contagion effect, this theory breaks down. When you need the theory most, it lets you down worse. That's the trouble. When you don't need it, everything, the ship in the ocean calm going, it works fine. Okay, I better then, I have a whole, these things are, I've also discussed the market efficiency argument, but I don't have time and I just want to stop. Just let me finish by just go to the concluding remarks. So basically, what I have done is to focus on limitation of these rational hypotheses. Again, I'm repeating, I'm not saying this is not a good research program. I'm saying it's limited. It has got some benefit, but you cannot use it to explain everything and then just leave it at that level. And basically, the fundamental problem is that we do not know the parameters of these models. And these parameters are changing in a sometimes very complicated manner. And therefore, allowing for them is essential. We're dealing with a complex system. And the degree of market efficiency, I just didn't give you the discussion, really varies across time. And therefore, it's not true that either the markets are always inefficient or always efficient. That's, you clearly see, I haven't shown you the slide. You can see from my analysis of heterogeneous agent with diverse belief that actually it is the fundamental characteristic of this situation. So given that there are continually changing nature of the markets and economies, you really need to think more about robust decision making which allows for learning, rather than basically assuming that equilibrium exists and you don't need to do anything about it. And finally, the correlated behavior due to herding or other, I'm using herding one example, on contagion also needs a special attention, because these are the ones which create non-stationarity in a significant way in the economic system. I'm sorry that I didn't be able to have some of the part, but I'm sure the future arises. Thanks so much.
Are there any questions for Professor Pisarum? Can I ask you one?
Sure, of course.
As a practitioner, you've essentially said, although the models are good, the problem is you can't find the parameters, so you can't use the models to determine asset prices. Is that a view you would hold of the determination?
Generally, I'm not saying in all cases, but I mean, obviously, the point here is that if you say that there is an asset which the life of it is 2 years and the world is stationary, probably you could do it. But in general, you cannot make a claim.
Right.
I just wondered, you know, in your statement that the fundamental price doesn't exist because moments don't exist, are there alternative methods of trying to determine? I mean, you must have thought about, instead of performing a regression, for example, if you use some other technique for fitting, as you're often forced to when you have systems that have moments that don't exist, is there any alternative?
I did explain, if you had a learning, like Bayesian learning,
Yeah.
it would give us the same problem.
Yeah. So, but there you have the problem even when it's Gaussian.
Yes, it's Gaussian.
Right. But I'm just wondering whether, so you think it's inherently impossible to make a valuation when the moments don't, when there's a cutoff on the moments?
I think that either you have to say, I want to cut off, for example, my horizon is 20 years or 5 years. You just have to say that. You cannot just say, therefore I hold this asset forever. What would have happened? I'm saying this question has to be changed. That doesn't mean that we should not be using this kind of, if you like, instruments of analysis. I'm not suggesting that. I say there are limitations to it. I was trying to give examples. And that is intuitive. If I want to forecast, say, 100 years from now, I need to have more data in the past to be able, even if the world was stationary, right? The problem is that we don't have enough data often to find out what are the variables that we need to forecast, say 10, 20, 30 years. The same applies to the environmental issues that people are discussing. So this problem is not only in finance, but I think any human endeavor which tries to look way into the future and try to be too rational requires a knowledge which we don't seem to have. Unless we become more modest. We say we don't want to really know what is happening in 100 years' time in some way, or the effect of it. Shorter time. But then there's other problem. The problem non-stationarity then comes back. Those examples were where everything was stationary. Now, if you have non-stationarity, even short term could be a problem.
One last
Just
question.
make, I mean, to return to your question there, the Bayesian analysis breaks down because in effect what you've done is you've taken a prior that puts mass on values of mu, which would lead to an infinite price. Now, if you don't believe that the price of this asset can be infinite, your prior should not put mass on those things. And if you actually take a Gaussian prior but multiplied by some pre-factor, which eliminates the bad values of mu, you can get a perfectly sensible answer.
Yeah, but the problem is that if you have non-stationarity, then you don't know that actually what is the learning going to lead to. You see, your example is that I can fix it by truncating something effectively. You can truncate the edge, you could just the same effect. And that's what it's saying. It doesn't help you at the end in a complex world.
It needs fixing.
Hopefully somebody would fix it.
Just to amplify, then you might worry that the answer you get will depend sensitively on your prior, in which case you're just guessing.
Correct.
That's exactly right.
That's a potential problem.
I think I see a subject for the panel discussion shaping up rather nicely here. Okay, Professor Pisarum, thank you very much.